Hi, this is Alex from devstories.eu. Kubernetes and Helm Fundamentals, Episode 5 of 10. Pods are mortal. They crash, they scale down, they get evicted, and when they are replaced, they get an entirely new IP address. If you have an application trying to communicate with them, you are constantly shooting at a moving target. Kubernetes Services resolve this exact problem. Think about a typical web application. You have a front-end deployment and a back-end database. If your database pod restarts, the cluster control plane spins up a new pod to replace it. This new pod is assigned a completely different IP address on the cluster network. If your front-end was configured to talk directly to the old IP, the connection drops and your application breaks. You cannot rely on individual pod IPs for anything permanent. A Kubernetes service is an abstraction that provides a stable, long-lived network identity for a dynamic group of pods. When you create a service, it is assigned an IP address that will never change as long as the service exists. Your front-end application does not need to keep track of exactly which database pods are alive at any given second. It simply sends traffic to the service IP. Furthermore, the cluster assigns a stable DNS name to the service. Your front-end code can just connect to a simple host name, and the cluster automatically resolves that to the correct IP address. Behind the scenes, the service acts as an internal load balancer. It relies on a component called kubeproxy running on every node to implement the actual routing rules. When traffic arrives at the service, it is forwarded to one of the healthy pods backing it. To link a service to the right pods, you use labels and selectors. You might configure the service with a selector looking for the label indicating a database application. The service constantly watches the cluster. If a database pod dies, its IP is removed from the active pool. When the replacement pod boots up, its new IP is added. The front-end application remains completely unaware that the underlying network topology just shifted. There are a few ways to expose a service, depending on where the traffic originates. The default type is cluster IP. A cluster IP service gets an internal IP address reachable only from inside the cluster. This is the correct choice for your backend database, keeping it securely isolated from the outside world. But your front end needs to receive traffic from external users. For this, you change the service type to load balancer. When you create a load balancer service, Kubernetes communicates with your cloud provider to provision a standard external load balancer. External internet traffic hits that cloud resource, which forwards the connection into your cluster, passing it through the service and finally to your front-end pods. Here is the key insight. Services decouple the addressable identity of your application from the physical workloads actually executing the logic. You stop routing to specific, fragile instances and start routing to a resilient, persistent concept. That is all for this one. Thanks for listening and keep building.